Hi everyone, I am Daehyun Kim, a PhD student at Stanford, and I'll be talking about chart question answering with explanations, with a focus on this last bit, explanations, based on work with Enamel Hoke and Manish Agrawala. This is a chart from Pew Research report about a survey done on Chuck Plains about prevalence of religious extremism among inmates. The y-axis of this chart shows religions, and the x-axis shows the percentage of responses either common depicted by orange or not common depicted by blue. Answering the question, for which religion did the fewest Chaplains think that religious extremism is common, requires an understanding of the chart. A chart question answering system takes chart question pairs like these and outputs an answer such as Orthodox Christians and Hindus. And many works on chart question answering have focused on accurately generating answers. I would like to shift our attention to the users of the question answering systems. From the user's perspective, a key weakness of many existing systems is transparency. Given just the answers, a user cannot determine how the system interpreted the input question and what the system evaluated to obtain the answer. To verify the answer, the user must go through the burden of coming up with a procedure for answering the question and manually performing the procedure to obtain an answer. At the same time, chart question answering is a field of active research with much room for improvement. So if the user cannot easily verify the correctness of the answers, it would be difficult for the users to trust the system. Pairing answers with explanations of how the system computed the answers is a way to address the issues around transparency and trust. Here the explanation, I looked up religion for the shortest orange bars, indicates that the system performed an argument operation on the orange bars that correspond to the response common. With the correct answer, the user can see that the system interpreted the question correctly and performed correct operations to get the answer. To obtain an insight into the properties of effective explanations, we looked into how people explain their answers to questions about charts through a formative study. We started by collecting 52 charts from sources such as Pew Research reports or the Vega Lite example gallery and rendered them in Vega Lite. We first asked workers on Amazon Turk to write a question about a given chart. For example, the Turker would type in which religion has the greatest value for common. Then we asked the second set of participants to answer the questions and provide explanations for their answers. For example, the participant would type in Muslims for the answer, and I picked religions with the greatest orange percentage for the explanation. Through this process, we collected a total of 629 questions and 748 explanations for answers. Through an examination of the collected explanations describe a procedure for computing the answer, such as filtering, comparing, or aggregating values. A rather interesting finding was that half of the explanations referred to visual features of the chart and showed how the chart was used while performing the operations. Let's look back at the explanation that the participant wrote. This explanation not only describes the performed argmax operation, but also directly refers to the orange bars in the chart to show how this operation was performed in the context of the chart. But should we expect that such visual explanations would be useful to the ones who read the explanations? Let's look at the stacked bar chart, showing yield of different varieties of barley at various sites. This chart shows the varieties on the y-axis and the yield on the x-axis, and uses colors to encode sites. Notice that it is much easier to locate green component in the top bar than it is to locate glabron at University Farm, although they refer to the same thing. A possible explanation for why is that we can pre-attentively locate the visual element using the color and location mentioned in the former, whereas the latter requires serial search. So it appears that the visual explanations would be useful for people. Based on these observations, we built an end-to-end chart question answering system that generates explanations. Our pipeline builds on the work by Pasupar and Liang. Their system, called Sempre, takes as input a table like this table showing information about historical Olympic Games, and a natural language question about the input table, such as Greece held its last Summer Olympics in which year, and outputs an answer for the given question, which would be 2004 in our example. The reason why we found this system as a good starting point is because we can extract the formula used to compute the answer in a form called the lambda expression. We can use this lambda expression to generate an explanation. In our chart, we start with a chart and a question about the chart. As an illustration, we will use the chart on religious extremism and the question, which religion has the shortest orange component? To make Sempre accept our input, we extract the underlying data in the chart and format it into a table, and convert the question about the chart into a question about this table. Here, our question is converted to, which religion has the least common percentage? Notice that the question no longer has references to the visual elements of the chart, such as shortest and orange. For further details about this procedure, please refer to our paper. We input the resulting data table and the question into Sempre and obtain the answer to our question, Orthodox Christians and Hindus. To generate an explanation for our answer, we extract the lambda expression that was evaluated to obtain the answer. From this lambda expression, we use a sequence of rules and templates to first generate an explanation without any visual references to the chart. Here the system generates the explanation. I looked up religion with the least percentage of common, which achieves the primary goal of explaining the operations performed on the data to obtain the answer. Then from this non-visual explanation, we use how the chart encodes data to create a visual explanation that directly refers to the visual elements in the chart. In our example, the converted explanation would be, I looked up religion for the shortest orange bar, which refers to the visual features, color, and length. Let's look at some more examples generated by this pipeline. This is a chart showing the house effects of various posters, which are systematic tendencies for the posters to favor certain parties. The y-axis lists the various posters, and the x-axis shows the amount of house effects. The orange bars to the left of 0 indicate Republican house effect, and the blue bars to the right of 0 indicate Democratic house effect. To the question, what is the difference between the value of Gallup and Quinnipiac? Our system outputs the answer 0.8, which is correct. By converting the lambda expression used to compute the answer, the system also outputs the explanation. I computed the difference between the length of the bar for Gallup and Quinnipiac. This explanation shows that it applied the difference operation on the length of the two bars, which encode the size of the house effects. Based on the explanation, one can see that the system correctly interpreted the question and performed correct operations to obtain the answer, and infer that the answer is correct. For the question, what position is Ipsos in? Our system outputs the answer 2.9, which is incorrect. Again, the system converts the lambda expression it used to compute the answer into the explanation. I looked up the length of the bar for Ipsos. The user can see that, although the system detected the entity Ipsos correctly, it misinterpreted the ranking operation and instead looked up the value, leading to the error. Over multiple rounds, the user could quickly form expectations of what the system can handle correctly and why, and even go further to improve the system. For our system, the user could learn that it does not support the operation for ranking after a few iterations. With these explanations, we ran a user study to see the effect of explanations on transparency and trust. Our hypothesis for the user study is that visual explanations increase transparency and trust. For each chart question pair, We included answers and visual explanations generated by our pipeline, and included an answer-only, no explanation condition to confirm our hypothesis. In addition, we included the non-visual explanations created by our pipeline to check if the references to visual elements help transparency and trust. Finally, we included human-written explanations from the formative study for comparison. For the study, we recruited 16 participants. Each of the participants were shown 20 chart question-answer explanation tuples, 5 per explanation type. We first had the participants perform the task of determining the correctness of the answers. Then we asked them to evaluate the transparency of and the trust towards the system and the usefulness of the explanations on a 5-point Likert scale. Finally, we collected free-form responses about transparency, trust, and usefulness, as well as any other comments they had to share. Our system got an average rating of 3.9 on a 5-point Likert scale for transparency. And this was significantly higher than the no explanation condition, which received only 1.3. Compared to the non-visual explanation condition at 3.4, transparency was higher with the visual explanations, but the difference was not significant. Even when compared to human-generated explanations at 3.3, our visual explanations were significantly more transparent, probably due to the consistent yet simple structure arising from the templates and rules used for their generation. For trust, our visual explanations scored 3.3 on a 5-point Likert scale. This is higher than the no explanation condition at 3.0 and the non-visual explanation condition at 3.1, although the differences were not significant. Also, the trust towards the visual explanations was very close to that of human-written ones at 3.3. In sum, visual explanations do improve transparency and seems to improve trust. Finally, I'll share some thoughts about future directions. Let's look again at this chart, this time with the question, how many religions had at least 30% of common? The answer for this question is 2. And the visual explanation, I counted the number of orange bars longer than 30%, is one way to shine light on what happened in the middle, and there are other ways we have not explored. It is possible to provide anchors in the input that led to the operations in the first place. For example, we could indicate that how many in the question is how the system knows to count, and that the word common in the question and the legend in the chart are how the system knows to look to the orange bars. It is also possible to bridge the gap between the explanation and the answer by providing intermediate results. Here, orange bars longer than 30% would correspond to Muslims and pagan earth-based, which the system then counts to get the answer to. It could be possible to provide explanations graphically on the chart for questions with simpler operations. There are many other ways explainability of chart question answering systems could be improved. Determining which are the most effective for chart question answering and the specific method used would be key in building transparent and trusted systems in the future. Thank you.